Good evening, everyone. Welcome to week 5 assignment solving session. Today I'll be discussing questions related to week 5 lecture materials and week 5 assignment questions. So let's start. So the first question is in gaseous state, the structure of BeH2 consists of option A is both monomeric and dimeric. B is one-dimensional polymeric with hydride bridges. C is two-dimensional polymeric with hydride bridges, and D is three-dimensional polymeric with hydride bridges. So in gaseous state, BH2 will exist as both monomeric and dimeric form. In monomeric, it will be in the linear form BeH2. And in dimeric form, B will get sp3 hybridized and forms a 3-center 2-electron bond with hydrogen bridges. So beryllium in ground state, it has a 2s2 2p0 configuration. And when it gets excited, comes 2s1 and 2p1. So all these orbitals get hybridized to give sp3 hybridization. So beryllium will have, that will be 4 sp3 orbital. So 4 of them will be present. And only 2 of them will have electrons. And those having electrons will form a bond with hydrogen having 1 electron. So there will be another beryllium as well. So here again 2 electrons, and this forms bond with hydrogen. And so there is a vacant orbital. So this interact with the nearest hydrogen. So these forms a bond. And here also this one is vacant. So this hydrogen interact with this vacant orbital, forming a bond here. So that will be 3-center 2-electron bond. So it will exist as BeH. So in gaseous state, BH2 has both monomeric linear structure and a dimeric 3-center 2-electron bond formed dimeric structure. So option A is the answer. Next question is Bu3P Cu CH2 CD2 C2H5 decomposes in solution to give option A Bu3P CuD plus CH2 double bond CD C2H5. B is Bu3P CuH plus CD2 double bond CH C2H5, and C is Bu3P CuD plus CD double bond CH C2H5, and D is Bu3P CuD2 plus CH2 double bond C C2H5. So this is an example for beta elimination reaction, and beta elimination happens when there is hydrogen present on carbon and beta position of metal. So here we are given the metal copper. So we can start with an example. If there is metal coordinate to other ligands, here Ln is Bu3P. So for example, we will take Ln and metal and CH2 CH3, and we can rewrite it as Ln M CH2 C H2 H. This CH2H is CH3. So in beta elimination, what happens is that the hydrogen present on the beta carbon to metal center, it gets migrated to metal and an alkene is formed. So here this is the alpha carbon, this is the beta, so this is the beta hydrogen. So this bond breaks. So here a double bond formation occurs and this hydrogen migrates to metal. So it gives Ln M H plus CH2 double bond CH2. So this is the beta elimination. Here we are given Bu3P, copper, then CH2, CD2, C2H5. So we can count the carbons, alpha, then this is the beta carbon. So the hydrogen or deuterium present on the beta carbon should be eliminated and migrated to copper. So it will be U3P, Cu, CH2, C, D, D, and C2H5. So this bond gets broken and this D gets migrated to copper. And it will give Bu3P, CuD plus CH2 double bond CD C2H5. So we have the answer here, and CH2 double bond CD C2H5. Option A is the answer. Next question is pure boron has composition. Option A is B10, B is B11, C is B12, and D is B9. So pure boron exists in an icosahedron structure. So this is the icosahedron structure. It has 12 edges. So in each edge, boron is present. So in if this is a icosahedron structure, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 12 edges are present. So each edge will be occupied with boron. So there will be 12 boron in pure boron. So option C is the answer. Next question is group 2 nitride M3N2 react with water to give. Option A is 3 metal hydroxide plus 2 NH3. B is a complex hexacoordinated complex of water with metal and nitride. Option C is 3 metal hydroxide and N2H4, and option D is metal oxide and N2. So when nitrides react with water, hydroxide and ammonia gas are produced. So equation will be M3N2 plus H2O giving MOH twice plus 2NH3. We need to balance the equation. So there are three metals here. So it will be 3 metal hydroxide, and there are 2 and here, so it will be 2NH3. So balancing here, there should be 3 water molecules. So uh, so the answer is option A. Next question is the reaction of calcium carbonate with acidic soil results in option A is calcium oxide and water, B is calcium hydroxide and water, C is carbon dioxide and water, and option D is calcium ion, water and CO2. So reaction of calcium carbonate with acidic soil. So this is one of the method to balance the pH of soil. So calcium carbonate react with protons in acid forming calcium ion, water and CO2. So equation will be CaCO3 plus 2H plus giving the calcium becomes calcium ion plus uh, there are there's a carbonate, it becomes carbon dioxide, CO2 plus one oxygen is remaining, that forms bond with 2H plus giving H2O. So the equation is balanced. So the option D is the answer. Next question is barytes, that is barium sulfate, react with coke to give. Option A is barium sulfide plus SO2 plus CO2. B is barium oxide plus SO2 and CO2. Option C is barium sulfide and CO2. Option D is barium sulfide and 2CO2. So barium sulfate can react with coke and it can form CO2 gas, barium sulfate BaSO4 plus C will give barium sulfide and CO2. So there are 4 oxygen here, so it should be 2 CO2 and 2 carbon. And if there is excess carbon, it can also form barium sulfate plus 4 carbon will give barium sulfide plus carbon monoxide. So it will be 4 carbon monoxide. So this is also possible, but major product will be barium sulfide and 2CO2. Yeah, option D is the answer. And next question is the organic molecule formed in the hydrolysis of calcium carbide, that is CaC2, is option A is CH4, B is C2H6, C is C2H2, and D is CH3C triple bond CH. So in calcium carbide, there are two carbon. So the product should have only two carbon. So in the answer there are two options with two carbons, and we can neglect other two answers. So when calcium carbide react with the water, it will form a calcium hydroxide and ethylene. So CaC2 plus 2H2O will give CaOH twice plus C2H2. So option C will be the answer, and all second group carbides will give ethylene on hydrolysis of carbide, except carbide of beryllium. So beryllium is Be2C. So when it react with the water, it will form methane, BeOH twice plus CH4. So we need to balance the equation. So 2 beryllium, so it will be 2, and uh, 4 oxygen are there, so 4H2. So point is that all second group carbides uh, give except Be2C. Carbides are in the form of MC2. Next question is, magnesium burns in nitrogen to form. Option A is magnesium N2, B is MgN X times, C is Mg thrice N2, D is Mg2 N3. And this is a direct question. Magnesium nitride is formed when magnesium burns in nitrogen, and the formula of magnesium nitride is Mg3N2, where magnesium is in the +2 oxidation state and nitrogen in -3 oxidation state. So option C is the answer. Next question is, with respect to the following statement, the correct option is, first one is, all carbonates are sparingly soluble in water with exception of beryllium carbonate. Second one is, the carbonate decompose to corresponding oxides on heating. 3 is, the hydrogen carbonates are less soluble than carbonates. And fourth one is, the thermal stability of group 2 metal carbonates decrease down the group. So let's go through each statement. So all carbonates are sparingly soluble in water with exception of beryllium carbonate. So all the statement is true. From top to bottom, the stability of carbonates increase because increase in cationic size. So solubility uh, decreases down the group, and beryllium has highest hydration energy in the group, so beryllium carbonate is highly soluble. So this statement is true. And next one is, the carbonates decompose to corresponding oxides on heating. The statement is true because when we heat it, MCO thrice, and it's heated, it will give MO, that is metal oxide, and CO2. So the statement is true. And next one is, the hydrogen carbonates are less soluble than carbonates. So this statement is false, and the bicarbonate, that is MHCO3. So they are highly soluble compared to carbonate because they can decompose to M2 plus and HCO3 minus easily compared to M2 plus and CO3 2 minus. So this decomposition is more favored compared to this one. So this one is highly soluble. So this statement is false. And next one is the thermal stability of group 2 metal carbonates decrease down the group. So the statement is wrong. When moving down the group, the stability of carbonate increases. So this one is also wrong. So the option B is the correct answer. Next question is aluminum hydroxide on heating gives. Option A is alumina and 3H2O. B is aluminum plus 3 water, and C is a complex of aluminum and aluminum hydroxide, and option D is aluminum hydride and oxygen. So when heated, aluminum hydroxide is LOH thrice. So when it is heated, it will give alumina, that is aluminum oxide, L2O3 and H2O. So we balance this 2 aluminum oxide, L2O3 plus 3H2O. So option A is the correct answer. So next question is, among the following species, amphoteric oxide is, option A is calcium oxide, B is barium oxide, C is sodium oxide, and D is beryllium oxide. So in the group 2 oxide, basicity increases when we move down the group, and because of the small size of beryllium, it shows uh, different properties compared to uh, other group members. So beryllium oxide has amphoteric oxide. Next question is, magnesium burns in air to give. So option A is magnesium carbonate, B is magnesium oxide, C is both magnesium oxide and magnesium nitride, and D is MgN2. So in air, there is both O2 and N2 present. So magnesium can react with both oxygen and nitrogen. So it will form Mg plus O2, giving 2 MgO, that is magnesium oxide, and magnesium can react with N2 to give magnesium nitride. So option C is the correct answer. Next question is, the increasing order of melting point of group 2 metal oxide is, option A is beryllium oxide greater than magnesium oxide, greater than calcium oxide, greater than strontium oxide, greater than barium oxide. B is beryllium oxide is greater than magnesium oxide, greater than strontium oxide, greater than calcium oxide, greater than barium oxide. Option C is magnesium oxide greater than beryllium oxide, greater than calcium oxide, greater than strontium oxide, greater than barium oxide, and option D is beryllium oxide greater than magnesium oxide, greater than calcium oxide, greater than barium oxide, greater than strontium oxide. So the melting point of oxides in group 2 is uh, given here. So melting point is directly proportional to the lattice energy, and while moving down the group, lattice energy decreases due to increase in size of the cation. So the order of melting point decreases down the group. So magnesium oxide has a higher melting point compared to beryllium oxide. So the option C is the correct answer. Next question is structure of barium chloride and calcium iodide are respectively. Option A is both linear, B is bent and quasi-linear, C is bent and linear, and option D is quasi-linear and linear. So if you have watched the lecture, uh, week 5 lecture, there is information about the structures of chlorides, iodides and other halides of group 2 metals. So it's given here, and because of the uh, larger size of um, calcium, strontium and barium, they'll show different structure than linear. So usually if it's mm, uh, it's a if it's a metal halide of group 2, it's expected to have a linear composition with 180 uh, degree angle, but moving down the group, the size of the metal increases. So to minimize the repulsion, they become bend structure and quasi-linear. Quasi-linear is uh, when there is an energy difference between linear and bend structure less than 4 kilojoule per mole. So some of the metal halides have quasi-linear. That is, most of the halide of calcium has quasi-linear, and for strontium from chloride, bromide, and iodide, all three has quasi-linear, and for barium, only iodide is quasi-linear. So we are asked to find the structure for barium chloride. Here, barium and chloride. So it is a bend structure for barium chloride. And for calcium iodide, calcium and iodine, so it is a quasi-linear. So CaI2 is quasi-linear. So option B is the correct answer. Next question is solid state structure of BeH2 corresponds to option A is linear, option B is 1D polymer with hydride bridge, and option C is two-dimensional polymer with hydride bridge, and option D is three-dimensional polymer with hydride bridge. So in solid state, BeH2 exists as a polymer, and in gaseous state, we have discussed it in the previous question. In BeH2, gas will be monomer and dimer, and BeH2 solid is a polymer. It will be 1D, one-dimensional polymer. So beryllium is in sp3 hybrid form. So 4 sp3 hybrid orbitals and only 2 electrons. And this forms bond with hydrogen, and nearby another beryllium. So this hydrogen forms bond with this beryllium, and they form a 3 center 2 electron bond. And here also it extends in 3 dimension. So we can rewrite it as Be H H, and so this extension all linearly in 1 dimension. So answer is 1D polymer with hydride bridge. Next question is the formula of magnesium carbide is and its carbide ion is isoelectronic with option A is Mg3C2 plus CO2, B is Mg2C3 and O2, C is Mgc2 plus N2, and D is Mg2C3 plus CO2. So among group 3 carbides, beryllium forms carbide of the form Be2C. Calcium forms calcium carbide. It's in the form of CaC2, and magnesium forms Mg2C3. So the formula of magnesium carbide is Mg2C3, and we here in Mg2C3 the oxidation state of one magnesium is +2. So overall Mg2 will be +4. So C3 should be -4. So C3 is in -4 state. So we can rewrite it as C and C2 4 minus, and again that will be carbon, and one carbon will be C2 minus and C2 minus. So carbon and 2 electrons will be oxygen. So it will be CO2. C3 4 minus is isoelectronic with CO2. So the answer is option D. Magnesium carbide having formula Mg2C3, and carbide ion is isoelectronic with CO2. The next question is calcium nitride Ca3N2 react with hydrogen gas at high temperature to produce. Option A is calcium amide and NH3. Option B is CaNH and CH2. Option C is calcium amide and CaH2, and option D is calcium amide and ammonia. So calcium nitride reacts with hydrogen at a very high temperature, and it will produce calcium amide and calcium hydride. So Ca3N2 at H2 gas and about 4000 degrees Celsius, it will give CaH2 plus CaNH. So option B is the correct answer. And Next question is beryllium carbide, that is Be2C, on reaction with water gives beryllium hydroxide, and which of the carbon compound is formed. So in Be2C only one carbon is present. So uh, uh, can you please turn off your mic? Okay, thank you. So beryllium carbide has only one carbon. So only a product with one carbon should be formed. So here either methane or CO2 will be forming. So we are asked to get reaction with water, B2C plus H2. So it's giving, we are given one of the product, that is beryllium hydroxide, BeOH twice, plus what is the next product is asked. So when hydroxide is formed from water, that is H plus OH. So OH is forming bond with beryllium to form beryllium hydroxide. So hydrogen is left. So it forms methane. So if there are four water molecules present, uh, there will be two beryllium hydroxide and methane forming. So option B is the answer. Next question is basic beryllium acetate consists of, option A is a central oxygen atom surrounded by a square planar of four beryllium atoms. Option B is a central oxygen atom surrounded by a square pyramid of four beryllium atoms. Option C is a central beryllium atom surrounded by a octahedron of six oxygen atoms. And option D is a central oxygen atom surrounded by a tetrahedron of four beryllium atoms. So this is the question from week 5 lecture. So the structure was given. First, this is the structure for basic carboxylate or beryllium acetate structure. So it is formed by reaction of beryllium hydroxide and uh, acetic acid, that is CH3 COOH. So it gives Be4O OOCr 6 times. So uh, the structure is given here. So this O is surrounded by 4 beryllium in tetrahedral fashion. So option D is the answer, a central oxygen atom surrounded by a tetrahedron of 4 beryllium atoms. Next question is the melting point of calcium halides decrease in the order. Option A is calcium iodide greater than calcium bromide greater than calcium chloride greater than calcium fluoride. Option B is calcium fluoride greater than calcium chloride greater than calcium bromide greater than calcium iodide. And option C is calcium bromide greater than calcium iodide greater than calcium fluoride greater than calcium chloride. And option D is calcium chloride greater than calcium bromide greater than calcium iodide greater than calcium fluoride. So the melting point of halides while moving down the group uh, should be uh, decreasing, because among halogens while moving down the group electronegativity decreases, because and the size of the halide ions increases. So when they form calcium halides, the ionic character decreases down the group. So lattice energy decreases down the group. So order of melting point decreases down the group. So uh, highest melting point will be for CaF2 because that is having most strong bond because of higher lattice energy, then calcium chloride, then calcium bromide, then calcium iodide. So option B is the answer. So the next question is, a group 2 metal M dissolves in liquid ammonia to form a compound A, and A slowly decomposes to B and carbon and C, which is a gas with liberation of ammonia gas. And metal M on a flame test gives a crimson red color. So identify the metal, then A, B, and C. So we can write down the reactions. First given, M dissolves in liquid ammonia. So it is giving compound A, and given A slowly decomposes to B and C. So it decomposes to give B and C plus NH3. So it is also given flame test give crimson red. So from the flame test, we can identify the metal ions. So here we are given crimson red color. So strontium forms the crimson red color in the flame test. So the metal will be strontium. And when metal, that is group 2 metal, dissolves in liquid ammonia, it forms hexacoordinated ammonia complex. So that will be M NH3 6 times 2 plus. This will be the complex, and uh, we know the central metal, so it will be complex of strontium. So this is A, and we are given A slowly decomposes to B. So uh, when during decomposition, it forms metal amide, that is M NH2 twice plus H2 gas plus ammonia. So we are given C is a gas, so H2 is the gas here. So this is the C, and strontium amide will be the option, the B in the question. So M is strontium, A is the complex of ammonia, and B is amide, and C is hydrogen gas. The next question is group 2 metal X occurs naturally in great abundance as carbonate. X reacts with water forming compound D, which is a strong base, and aqueous solution of D are used in qualitative test for CO2. X combines with H2 to give saline hydrate that is used as a drying agent. Identify X and D. So we are given X is a group 2 metal and it naturally occurs as carbonate. So it is XCO3. And alkaline metal react with water to form metal oxide and it liberates H2. Uh, so X plus H2O giving metal oxide and H2 gas. So the metal oxide will be D and we are given X combined with H2 to give saline hydrate. And aqueous solution of D is used in qualitative test for CO2. So for the qualitative test of CO2, we usually use calcium hydroxide or aqueous solution of calcium oxide to test for CO2. So M will be calcium. Here it's X. So X is calcium. So calcium in water will be giving calcium oxide and H2 gas, which is the D. And in calcium oxide in water will form calcium hydroxide. So this solution will be used for qualitative test for CO2. Plus CO2 will be KaCO3 plus H2. The next question is which of the following compounds are soluble without reaction and which react with water? So there are some of them are sparingly soluble. So heavier alkaline metal salts will be sparingly soluble. So it will be barium sulfate, magnesium carbonate, magnesium hydroxide, and calcium fluoride. So these will be sparingly soluble salts, and those are soluble but without reaction. They are beryllium chloride, magnesium chloride, calcium nitrate, and barium chloride. And last one is soluble with reaction. So calcium oxide will be soluble and it will react with water. So CaO plus H2, it will give calcium hydroxide, and strontium hydrate SR2 plus 2H2 will also form hydroxide. So these are all the questions I have for today's uh, tutorial. So if you have any doubts in the questions, you can ask.